Hello. I found out I am able to record with something that's already on my computer. Anyway, so all my issues I was having before, I think, are gone, hopefully. All right, graphing radical functions, 6-4 today. A radical function is a function with a radical symbol. Square root, we usually don't put the 2, but sometimes you see that little index. Or cube root, those are radical functions. I'll put x. And I'll show you why they're a function. Radical function are any root. So you could have, if you have an even index like 2, which I said we usually don't put, 4, 6, ... Your graph is only positive and kind of looks like that. If you have odd roots, cube roots, so cube root, fifth root, just like when we have an exponent of these things, seventh root, your graph basically looks like this. But you could also always graph it in a calculator or plug in values to find the general shape. Okay, let's talk about the square root function. So the square root function looks like this. I have so many things on my desk. This is the square root of x. Notice it starts on 0, 0, and it continues on. So square root of 1 is 1, square root of 4 is 2, so on. This one has no transformations because there are no extra numbers with that. If you had extra numbers, it would be moving around, flipping, reflecting, that kind of thing. So your domain for square root is greater than 0, and your range with no transformation, or your function, which is your y values, are greater than 0. Your x and y intercept is 0. Look at end behavior. The right side continues on forever to infinity, but the left side, as x is at 0, the function is also at 0. There's no infinity there. Increasing. Increasing is like if this was a roller coaster and you're here on top, you are increasing, reading left to right. Okay, so that's increasing. Positive. Positive means it's above the 0 line. Your y values are positive. Your function is positive. Okay, there's no symmetry because it's only one side. And when you're graphing them, make sure you include your arrow and you start at 0, 0, just a solid point. That is the square root function. I was trying to do something else, but okay, I was trying to verify this, but I can't on my old calculator right now. Square root function, this is with transformations. Now, a couple things they left out. You may have, so remember our transformations are inside the function or outside the function. So inside here is your inside the function. And then k is outside, a is outside. Now, a and b may have a negative in front, maybe. And if they do, they both reflect totally different directions. This one reflects around the x-axis. This one reflects around the y-axis. So a vertical reflect around this way, and this one's a horizontal reflect around that way. That line is not very horizontal, but you get the idea. Okay, A and B. A and B do the same thing. I'm going to write over here where I tested my pen. If A is greater than 1, that's a vertical stretch. Likewise, b greater than 1, it still gets narrow, but instead of vertical, we call it a horizontal compress. But either way, they're greater than 1, it's a stretch, or they get narrow. Okay, A and B. If A and B are fractions, A is between 0 and 1. Okay, not necessarily fraction, but a value between 0 and 1, because 5/4 is a fraction, but 5/4 is greater than 1. That'd be a stretch. You have a vertical shrink. If you had B between 0 and 1, you have a horizontal stretch. Either way, you are getting wider. Okay? So think of horizontal stretch, you're stretching out this way. Vertical shrink, you're shrinking down this way. So you're going wider. Here you're going narrow. Okay, the other two transformations are H. H is horizontal shift or translate. But remember with H, when it's inside, your H value is just H. It's opposite sign. So if you have a negative H, it's right. Your value is just H. A positive H is left. And then K is up and down. I'll just do that for K, up and down. And K, you don't have to worry about being opposite, just H, because it's inside. And I believe that's what everything says here. They didn't have B, but B is in the next example, so I wanted to make sure and show it to you. All right, example 1. Here we have this. We have two transformations. This one is a K, so it's up 1. That's easy because it's a plus 1. Now this one, you could think, what makes that 0? That's our H. So H is 3, so that's right 3. Another way you could think of the inside, the other transformation, is factoring out this 2. I get 2 as my B. And so B inside 2 still makes it narrow, but it's a horizontal compress, but I'm just going to put narrow. And then we see our H is 3. So it's not negative 3, our H value is just 3. Okay, so there's 3 transformations on that. You could also set the inside equal to 0. Get your H there. Now the graph, I'm not going to go back because we didn't do any transformations there. This graph moved up 1 and right 3. I'm not going to really graph how narrow it is, but so our new, if you want to call it vertex, is 3, 1. Okay? So it's going to start here instead of 0, 0, because it went right 3, up 1. And that changes our domain and range. All right, next one. We have 1, 2, I count that as 2, 3, 4 transformations. I'm going to write them right above. So negative, I'm going to write it to the left. I have lines here. Okay, so negative reflects on the X. 3 is a vertical stretch, which is narrow. H is, since it's plus 1, your H is actually negative 1. So that's left 1. And your K is a positive 2, which is up 2. That means where it starts, not our origin, but the vertex of the thing is HK. So it is negative 1, 2. And if you look at this, they graphed it for you. They went negative 1, 2. Now, you have the table and the graph here. I like zooming in because I don't know how big this is when you watch it. So on my calculators, on the Inspire, if you hit Control T when you have a graph up, it'll bring the table and that'll toggle the table on and off. But looking at the graph, so our HK is -1, 2. So that means our domain is to the right of that because it's going this way. So it's greater than or equal to -1. Our range, since it reflected, is less than or equal to 2 because it reflected. I wouldn't call that a maximum, but they do. Okay. Analyze the square root. So if you donate blood, they use a centrifuge afterwards to separate the red cells, the platelets, and the plasma. And they could donate those. People use those different things, not all your red blood as it is. Blood is red. I mean, all your cells as they are. Okay, so they need to have a specific RPM in order to separate to these three things. With the radius of 7.8 centimeters, the RPM setting is the product, so it multiplies 104.23 times the square root of the g-force. Okay, so that will give us RPM. This is words, variables, equations. I'm going to say RPM, and in our little graph, they call it R. Okay, so they don't call it here, but when they're talking about end behavior, they're talking this G and this is R. Okay, so here's our graph. It is real life info, so our range is R is greater than or equal to 0, positive, but not only because it's real life, it's the square root function, which usually starts on 0, 0. So again, here's our x-intercept is 0, our y-intercept is 0. It is increasing. It is positive because it's all above the x-axis. And the last one, they said they did the right end, which is this arrow. Oops, meant to circle. And they didn't do this end, okay? So this end behavior, this is the right side. So the left side is just 0. So you would say G goes to 0, R goes to 0, because they're both at 0, 0. Okay. Square root function. Inequalities. I think this is straightforward. It is less than, so you shade below. It's a dotted line because dotted lines are these symbols. Solid lines are those symbols. Open dot, because it is a dotted line. It's just you got this line right here where your shading begins. And you get that from this 2x plus 5 equals 0. X equals -5/2, which is -2.5. Or you could think of h. This is your h value. X plus 5/2, which means my h is -5/2. And it moved left. Okay. The shaded region are your answers. Okay, so that is square root. Before I go to cube root, I do want to point out we have parents are the functions with no transformations. So there is x squared. Square root is also a parent function because you could have transformations with that. And it kind of looks like that on its side. We're going to get into cubed root. So let's do the parent of cubed. It goes increasing left to right. It's going up. I'm going to write increasing right here. And then the cube root of x, the parent function, it doesn't just turn on the side, because if it turned on its side, it would be decreasing. It is also increasing. So you read left to right, you start low and go high. but do you see the similarity, the way they are shaped? And again, this is true for any odd power exponent. This is true for any odd index. Okay, cube root. Here is the cube root function. You have both ends. You have domain and range all numbers. Just like if you have cubed, fifth power, all your domain and range are all numbers. Positive and negative, it is positive here on the right, it is negative over here on the left. It is symmetric about the origin. So it is symmetric. I'm trying to think of, it's the same thing this way as this way, same shape. Okay, again, transformations, you just put cube root instead of square root, and let's do some cubes. Okay, here's my function. Only has one transformation, 1/3. There's no h and there's no k. So what it did was compress it, and you see how narrow this one is compared to this one, because it's 1/3 as tall. The domain is all numbers. Range is all numbers because it is cube root. Part B, only one transformation. Like they said, h is -5, so move left 5. So what usually would be on 0, 0, move left 5. So at -5, your y is 0. Cube root, you could take the cube root of 1 and the cube root of -1, but then other than that, they are decimals. And why I say 1 at -4 is because when x is 1, when x is -4, y is 1. Cube root of 1 is 1, because -4 plus 5 is 1. This one has 3 transformations, but looking at it like this is not x minus h. Remember, we need x minus h inside the function. So this is x minus h, and this reflects around the y, so vertically. And instead of increasing, it is decreasing. This is our k, so it moved up. This is our h, so it moved right. Okay, so our new, or what would be around 0, 0 is 4, 1. Again, all cubed, all cube root. Domain and range are all numbers. All right, here is square root and cube root. We're not going to compare them too closely, but just know square root of x kind of looks incomplete. Cube root of x has both ends going on forever. I'm not going to go over 328. So here your assignment's pretty short. For 2, 4, 6, I want you to tell me domain and range. And for, this is page 329. And for 8, 10, 12, I want you to graph them, sketch a graph, so you could do that on the same sheet. If you want to, try a couple on the next page, just so you know how to do, like maybe one inequality, and maybe a cube root, and maybe do odd, so you could check your answer in the back to make sure you understand those two. Your assignment's just square roots, but you need to understand the cube roots also. So maybe I should assign some from like 29, but oh well. All right, let me know if you have any questions.